everyone, and welcome. We'll get started here. So my name is Nicole Odo. I'm the Director of Digital Projects here at the Offsite Construction Research Center at the University of New Brunswick. Thank you for joining us today for our Transforming Construction 2025 to 2026 webinar series. A quick overview of how today's session will run. We'll cover a brief introduction to the Offsite Construction Research Center and our partner in these webinars, Building Transformations. We'll have introductions to our speakers, Claire Belerique, the marketing manager, and Ioulios Georgiou, digital architect at Horizon Legacy. Their presentation today is on construction, on-site robotics, and this is followed by a Q&A and discussion. Just a quick note for our Q&A. You can submit these at any time using the Q&A feature. So you'll see this beside the chat. It is separate from the chat. If you accidentally post a question in the chat, my colleague Rashni will move it into the Q&A for us. If you're having any trouble hearing audio or run it into any technical issues, please just let us know in the chat and we'll try and help right away. All of these sessions are recorded and will be posted to the OCRC YouTube channel, as well as the Building Transformations YouTube page. And we do follow up with the presentation slide deck, as well as a link to the recording. A bit about UNB. So the University of New Brunswick is the oldest English-speaking university in Canada, founded in 1785. It was the first university in Canada to offer engineering, forestry, and computer science programs, with the first engineering lecture delivered in 1854. We have two campuses, Fredericton, where I'm joining you from today, and St. John, both located in New Brunswick. UNB is home to over 25 research centers and institutes, including leading research chairs across multiple disciplines. Over the past decade, UNB has played a significant role in building New Brunswick's entrepreneurial ecosystem and was recognized as Canada's most entrepreneurial university by Startup Canada. Now, a bit about the Offsite Construction Research Center. The OCRC was founded through an industry partnership, and it remains central to who we are today. We've worked with over 80 industry partners across Canada, and our core values include things like applied industry relevant research. So this is why we work with so many industry partners, making sure that all of the work we do remains relevant to those who would actually be using it. Collaboration with industry and academic partners, research excellence, and integrity, including a strong commitment to equity, diversity, inclusion, and ethical research practices. And while our work is highly applied research, our role as a research center means we're committed to delivering objective, evidence-based outcomes. So things like this, where we do lots of knowledge sharing with as often as possible. So a few of our research themes and areas of expertise, we typically group these into 4 key areas. The first and second being process and productivity improvement and digital technology implementation. These often go hand in hand. A lot of times we are implementing digital technology to improve the process, but we've worked with companies in these buckets across a bunch of different research themes. Structures and building enclosure testing, including our new high-performance building research lab. And lastly, benchmarking, innovation, and construction research. This supports the industry as a whole, things like industry roadmaps, strategic planning, and things like that. Beyond our research, we also host webinars, conferences, and industry events, and we maintain an MOU with Northumbria University in Newcastle, UK. In 2024, we hosted the Transforming Construction with Offsite Methods and Technologies conference here in New Brunswick. And in 2026, the conference will be held in Newcastle, UK from August 18th to 20th. So please mark your calendars. We would love to see you there. If you've attended a past one, we would love to see you in the UK. If you have never attended before, this will be a great one to jump in on. So a bit about Building Transformations, who is our partner in these webinar series that we put on monthly. So Building Transformations has over 135 member companies. They have a strong and growing presence across LinkedIn and YouTube. Membership options for both individuals and organizations, with organizational membership covering everyone within the company. Building Transformations also publishes the Innovation Spotlight, available on their website, and hosts several in-person events. Sorry, I should have went to that slide while I was saying that. And this one. So this is their innovation spotlight. They're always showcasing great work that's happening in the industry, so be sure to check this out on their website. In-person events in 2026 are planned for Calgary in March, Montreal also in March, Phoenix in April, Halifax in August, and Toronto in October. So be sure to take note of these dates. Their next major industry summit is the one that's happening in Phoenix, Arizona. So we encourage you to keep that on your radar. And as always, we thank Building Transformation's mission partners, including their strategic and gold level supporters. Here is the information if you want to scan this QR code, or as I mentioned, we will distribute slides afterwards, so you can scan that when you get a copy. And these are the mission partners. And before we move on, I'd also like to thank the OCRC's partners, including the Government of Canada through multiple funding programs, OSCO Construction Group, who's our founding partner, and our marketing partners all listed here who help support, get the word out about everything we are up to at the Research Center. So with that, I'm pleased to welcome today's speakers. We have Claire Belerique, the marketing, forgot to update my notes, marketing manager. And we also have Ioulios, who's the digital architect from Horizon Legacy. As I mentioned, they'll be presenting on on-site robotics in construction. So I will hand it over to you now. Please go ahead and start sharing your screen. And I'll give you a thumbs up once we can see yours. All good to go.
Excellent. Thank you so much, everyone, for joining us today. You could be anywhere right now, but you're here with us, so we appreciate your time. We're Horizon Legacy. We are Toronto-based developers, and we're excited to share some of our learnings in our journey here in construction innovation. So right now you're looking at our project that's near completion in Gananoque, Ontario. So before we get too into that, be happy to proceed to the next slide and share a little bit about ourselves. So we all wear many hats. I work in business development as well as I'm the marketing manager. And I've been with Horizon Legacy for about 3 years now, working with the team, pivoting from experience in their renewable energy projects and managing high-rise projects, and then coming into fully focus on our ventures in innovation and construction. And Ioulios?
Hi, thanks for having us as well. I'm an architect. I have a background in digital fabrication and computational design. And I've been working with Horizon in the past 5 years as a digital architect, meaning design optimization and programming for 3D printing, so design to fabrication. And for the past 1 year, I've been project manager for our second residential development, which we'll be presenting today.
So we'll briefly go over an introduction of Horizon Legacy, our journey embracing innovation, a few global trends that we've acknowledged as well, and some information about our projects. So Horizon Legacy has been around for 70 years. We like to say that we're older than the Yonge Street TTC line here in Toronto. And if you're not familiar with Toronto, you may be familiar with the CN Tower that's shown just in the bottom left-hand side of the screen there. And all of those red markers indicate some of our projects that we have built, primarily around the Yonge Street line. And this was all built under the leadership of our founder, Walter Zwig, and then later on was then managed, owned, operated, and developed by his son, Tony Zwig, who is currently our chairman. And he decided to pivot with the organization. So this is a bit of our story in innovation, right? So we then got into renewable energy. We developed new renewable energy projects. Ioulios, just next slide there. We developed several addresses here. So we developed 1 St. Clair West, and notably 595 Bay Street in Toronto, and 400 University Avenue as well. So many of these buildings are still standing today, if not all of them, except one I believe is being redeveloped to an additional 12 stories on top of that. But yeah, we specifically on 33 Orchard View and 411 Duplex Ave, we added apartment buildings next to a mall. So something that was a newer concept for Toronto, and just kind of showing our path in innovation. And then just next, we went into renewable energy after we like to say, Toronto, there was a lot of developers around building high rise, and we felt a calling into renewable energy. So we developed projects from 2008 to 2023 in wind, solar, and water power projects. We owned, operated, and developed a portfolio of $150 million. And then during the calming and the completion of our last project, we really felt a calling to support housing. We found that there was a lot of finger pointing around, who is causing the driving costs of housing and why there's such a lag in building. And our chairman at the time, he bullishly asked, why don't we build with robots? So our team thought that we were crazy at the time, but as we started to look at different industries similar to what we see in the car manufacturing industry and the embracing of robotics, we started to understand the correlation with productivity. So we know that in construction, there's been little to no improvement in embracing new technologies. But this isn't something new. Like, we see people being redeployed as new technology comes in to replace the dull, back-breaking, and repetitive jobs, and seeing everybody being redeployed into other areas within the construction field. So this is something that we wanted to embrace as an organization and learn and play with the idea of using robots in construction. So we developed a 5,000 square foot construction automation lab. This is at the Downsview Airport lands. And so we have a hangar there where we developed one of the first of its kind in Canada for developing and testing and demonstrating and prototyping new robots. So you can see here on the left-hand side of the screen, this is our very first robot prototype. We called her Val 1. Now we have our Val 2 project robot that we developed that we'll share a little bit more information about. So this is something that we are really passionate about, is just learning and bringing new, younger people into construction and giving them tools that they may be more familiar with to encourage others to join construction as well. So here you see some of the, we think about robots in construction, it's not easy. We've developed a team, completely pivoting from a team of only 6 people before, and now we've grown to a team of about 20 folks. So we, no one better than Ioulios to explain our process and how we integrate our team with construction.
Thank you, Claire. Yeah, in principle, we're looking at a small team with multiple different disciplines. We have an automation technician who works on controlling the robot itself. We have a robotics engineer that is building these robotic systems and making them better and maintains them. We have a construction automation engineer because there's a lot of supporting equipment to the robot itself to make it part of the 3D printing process. We have a material specialist that works with the composition of the material, the mix of the concrete, because there's a lot of parameters that need to be adjusted for a print to be successful. We have electrical systems and technicians to make sure all the equipment is functioning while making it the entire system improved each time, making the automation process smoother. And we, of course, have general labor. It's not only, it's always necessary in each of the print and the R&D process to have general labor with us for the process. And digital architect, as we said before, would be design and coding to have the program that goes to the robot to perform the printing. So in general, it's a small team of multiple disciplines. So in order for the process to be successful, we're looking at the benefits of printing and why we started and why we keep developing this. So the first one is the labor efficiency. It is a smaller team with multiple disciplines. There is a labor shortage internationally in construction. And through printing, we are having smaller teams, but we are adding specialized positions in construction, so creating more work while keeping a small amount of general labor in the team itself. With the work customization, we mean instead of having the same repetitive product to achieve mass production, low cost and efficiency, we can have a product being varied in form through a pattern or slight geometry variation, and having that mass produced without really, in different forms, without really having an effect on its cost and time for that customization. We also we're looking at remote communities to bring our equipment there, to hire locally general laborers to bring our skills there. We also work as a general contractor in these projects. Of course, the key to all this is to increase the productivity, efficiency, and speed. So we try to make the robot move faster, to make the entire process faster, to positioning faster. And this is an ongoing process that has started 5 years ago, and it's still ongoing towards we reach the keywords construction automation. So it's a step-by-step getting closer to that. And finally, we are looking through the process to have a smaller carbon footprint impact and a smaller impact on the site itself, because we are indeed working with concrete. So we'd like to have a view of what's happening globally in the past decade in 3D printing at the large scale. So there's a different focus between companies in 3D printing. For example, on the upper right side, we see mass production automation. This happened by a company called Winsun, where the key was building 100 homes in 24 hours. So the key was speed. We have other examples, such as the one on the left. This is by a company, as you may know, Icon in the US. This is a combination of 3D printing and timber construction, which is something we also are doing, and we're going to look at it in our first building. And there's also we would call it a potential for organic architecture. It's a resurgence of a cultural context as well. So we see this example by emerging objects in Mexico. The same also applies to landscape architecture. This is a 59,000 square foot park in Hong Kong. Here, the freedom of geometry is expressed through prefabrication, through 3D printing. So these components taking advantage of the free form that is actually doable through printing and without formwork. So those were pre-printed in a lab and then transported to the site to create this new expression of form. Similarly, also in architectural design, there is definitely freedom in geometry. It has its limits, but it's also open up to new forms of architectural expression while bringing a rebirth to architectural concepts such as the ornamentation, reinterpreting classical components like the column, creating branching geometries through printing, and also using the geometric freedom at a smaller scale, as we can see in this Dior pop-up building in Dubai, where the organic form happens at a micro scale on a surface articulation through a pattern. This is done by WASP, the company. So back to what we do at Horizon. So in our lab in Toronto, as we said, we are talking about the large-scale concrete 3D printing, which means additive manufacturing. So using the robotic system, we extrude material in layers, And these layers have specific parameters. We work between 10 millimeters and 40 millimeters in layer height and 40 to 70 millimeters in width. Our speed of the robot started with 200 millimeters per second and can go up to 500 millimeters per second. So it's an ongoing process, being able to print faster and also make it possible. So there's, as you can see in the middle is our robotic system VAL 2.0, which is a 7-axis robotic manipulator, which we'll find out more in a bit. And on the left, you see one of our prototypes where the logo is basically formed through the print on one of our walls. So the creation of the material happens in the lab. The mix is advanced with each project. The robotic system is built in the lab. Systems are built in the lab. They're also advanced from project to project. And in general, the process of successfully printing requires multiple components. We have the material that is fed through the hose to the robot. So the material itself needs to be able to cure well enough to support itself while printing, but also not completely cure so that it can bond with the next layer coming into it. So there's a fine detail there in the material composition. And at the same time, the path needs to work, the robot needs to work, and the supporting equipment all need to be in sync for a successful print. And it's been a long process. Yeah. So now from a software point of view, we use design computation. So we form our geometries through 3D modeling, but also through parametric design. We use for it Grasshopper, which is the visual programming interface of Rhino 3D modeling. And there we generate the code that is to be printed. And the code is then controlled through Robot Studio, if you know the software, if you work with Robotics before, to locate exact collisions or vibrations that are caused through the robotic aspect of things. And in general, the entire design or optimizing a design for printing happens through this software pipeline. We are also looking at integrating this with Revit, a BIM process. So we're trying to do this in the next project, hopefully successful, to have a more cohesive design to fabrication pipeline. Again, it's another step to automation, but it's another aspect of automation that we're trying to achieve. But the main part, the main R&D happens in the lab. So it's what we actually print, and it's this cohesion of all these parameters.
So Ioulios was just sharing some examples of some 3D concrete printed walls that we've printed over in our lab facility. So this was crucial for us to be able to test the technology, as well as the mortar mixture that we developed in-house as well, and run it through a series of tests with our engineers and partners to be able to ensure that they could perform up to Ontario Building Code. So here we're looking at the ability for us to be able to manipulate the patterns and the textures for us to add different features to the concrete walls that would be typically a lot harder to form with traditional formwork. We've also found that it's a lot easier for us to be able to treat and inject pigment into just the surface of the concrete, which also offers us opportunities to save costs, because as we know, and we found that pigment is very expensive to add to concrete. Ioulios, welcome back. I took over.
Sorry about that.
That's
Please
okay.
go ahead.
And then here we are to just share that, this is happening here in Canada in some of our backyards as well. So this is our first project in Gananoque, Ontario. If you're not familiar with Gananoque, it's about 25 minutes east of Kingston. And this was important to us, this proof of concept. We invited lots of folks to our project site before we even started construction to understand the feasibilities and the costs. So we're excited to share that we are near completion. All folks will be moving into these units at the end of January, and we have built these units at under $300,000 per unit at hard construction costs there. So with this in mind, we built 26 rental units. So there's stacked townhome units that are all rentals. And we are finding a 67% less greenhouse gases consumed over the lifetime of this building. And as I previously mentioned, we have built this up to Ontario Building Code. So the specific 3D concrete printed walls are not load bearing. There is a traditional stick frame build on the interior walls. And then this was required to meet fire safety and Ontario Building Code for the actual strength of the walls. And it was our first project, right? We wanted to ensure that we were going to be successful in delivering this test. So the single story is built with 3D concrete printing, and we've added additional levels of automation throughout our process with our next project that Ioulios will share a little bit more information about. But going back to Gananoque, Ioulios, you intimately got to know this construction site in your time here on site and developing the project. So please share a little bit more information about your process and experience working with robots in construction.
Thank you, Claire. Yeah, it was definitely a challenge, the first building. So we used the VAL 2.0, as we shown before. And yeah, the print was only one story. We have to say it was a non-structural ground floor, and we printed the exterior walls of this building specifically. So it was a small team printing. At the same time, of course, there was stuff done in the conventional way. So we had to pour slab on grade, for example. And our other parallel work that was done next to printing, we did a quality control with each print. So the team was measuring humidity, temperature. We're getting samples of the walls to be tested. We're checking for potential displacements of the material, because again, it's a dripping material, it's concrete. So all this is also part of the process. It's a dirty process as well. So the VAL 2.0 was developed specifically to build walls like this. So it's a 7-axis robotic manipulator. So in principle, the robot has 6 axes of rotation, and added to that is the 7th axis, which is a horizontal rail where the robot is sitting on, making it able to print longer walls. Yeah. So the process itself, usually the valve moves from position to position to print. What happens is we load a code. First, we do a dry run without printing, so the robot just moves, checking for potential collisions that may happen on site, make sure that's in place. Then the robot is, of course, it's calibrated, and then when all is ready and all is in place, the print can happen. You can see here that we applied a pattern on the exterior side of the wall. And on the interior side, it's straight because of functional reasons, to be able to have a functional home. And you may also notice cuts that were done in the wall. So the material itself wasn't cured enough, so we were able to perform manual cuts. And these were essential to our then connections to windows and doors using wooden frames, and also to have thermal breaks. So in any case, before we went on site, we had to develop a strategy of printing, which is always a part of the process, is how to make as few printing positions as possible. So positioning and calibrating as few times as possible, and having a sequence of what print comes after the other. So for this one, it's pretty straightforward, but as the next project became more complicated, the sequencing can become sort of a puzzle at some times. So this was all simulated beforehand. So we were able through this process to also calculate how much material needs to be ordered, and be prepared for when we go to site. So as Claire mentioned, this is, I think these pictures were taken like a couple of weeks ago. It's coming to completion. So this is, we can see a bit of the pattern of the lower left picture. Of course, there's some post-processing there with the color as well on the wall. And we see its integration with with vinyl flooring at the same room, some of the cabinetry, some of the finishing for the kitchen. And this is how it's beginning to look like. Yeah, so at the same time, our second residential building has started construction. We are currently at the ground floor. And this is the project called Anidase. And Anidase is currently built in Six Nations, Ontario. It's an Indigenous land. It's a collaboration with Touro Architect, an Indigenous architectural firm, as you may know. And for this one, we are doing 3 stories of 3D printing, and it is structural and load-bearing 3D printed walls that we are using. Yes, so in this one, it's not only that it's load-bearing, but we're not only printing the exterior walls this time, it's also demising interior walls. So the main skeleton of the building is done through concrete 3D printing. And this required for the entire R&D development to reach this next stage. So it was a new robotic system. It was a new material composition. So making things faster, making things more efficient, a lot of material testing and structural testing to make sure our walls are performing structurally as intended. So this was a very close collaboration with testing facilities and also the structural engineer and architect to design new walls to make it possible. So the system itself has 3D printed walls that are load-bearing, are partition walls at the same time, are building envelope walls, performing thermally. There's parallel research that we're doing to make sure our walls are fire resistant, are functioning acoustics, and so forth. And this integration now becomes systematic because we combine it with different deck systems. For this one, we're using a composite metal deck that is going to be poured with concrete, but it also applies to looking at modular deck systems that can be combined with this. And after forming the superstructure, we also integrate flooring, some drywall, doors and windows, mechanical, electrical plumbing, then cabinetry, and to have a complete building system.
Yeah, I think it's important to just address that what we're looking at right now with our first project specifically, I believe what we produced was about 5% of the full construction costs were automated or built using our robot. Whereas with this project here, what we're aiming to do is build about 30% of the building as measured by construction costs with our robotic strategy. And what this means is what we're trying to do here is we're just trying to collapse all of the coordination and time and effort that goes into procuring different carpentry trades and all of the work that goes into the bricklaying and the work with laying drywall as well, and all of those trades collapsing under one trade that's now owned and operated by a robot operator and the supporting 4 staff that would be used to build. So we've hired we've hired local staff for all of our projects to help deploy and really just hone in on skills that they currently have in construction and then redeploy while using to support the robotic strategies. So I think it's important to address as well that, you know, we're not the only ones doing this. When we started this adventure back in, I believe, 2020, there's only a handful of companies globally that were looking into 3D concrete printing. Now there's projects going up every single day. So we're so happy to contribute to the success here in Canada in bringing construction innovation to the front line and celebrating this change, and along with others in the industry that we have found across the country. So lots of change is required at all levels of government and embracing new technologies. And we believe, and I found this little quote here, the pace of innovation is accelerating and the cost of standing still is higher than ever. We need more housing globally, and here in Canada more than ever. So anything that we can do to contribute to that drop in the bucket that can create a ripple effect to allow others to embrace innovation is something that we strive for. So thank you so much for everyone for attending today. You can follow our journey. We're going to be posting a lot of video footage of our construction project in Anita Say in this year. So please stay in touch with us, and we welcome any questions that you may have.
All right, thank you so much. We will get into the Q&A. So I'll just share my screen here. Okay, I think Roshni is moving some over. Okay, first question from Piero. Are you using the 3D printer for the structural floors? And if so, how?
No, we are not. So the floors are, I mean, the slab on grade is poured. The upper floors we are using currently, as I mentioned, the composite metal system. So it's basically a metal deck where concrete can be afterwards poured into it to form the slab. So it's a pretty traditional method. We're looking at modular deck systems to be combined later with printing, because for a modular system, we make the pace faster. So we'd like to cover the deck with the floor and continue printing. So again, it's another thought of automating the process, making the process faster. But no, it's not printed.
Great, thank you for that. Okay, from Sergey, how much energy can be spent for heating a concrete building compared to wooden made in Ontario?
That's a great question. We would have to get back to you. I want to respond to that in 3 months, because I think the true test will be going through a Toronto winter, or sorry, a Canadian winter here with our project, where we can measure that. I've heard claims of others in the industry that are saying that tenants have heated their entire unit with just the refrigerator. So there's a lot of claims and buzz out there about the technology, but we know that the thermal performance of these walls are 30 rating, which is meets and exceeds building code. So we're excited to learn a little bit more ourselves from our tenants that are living there.
Yeah, that'd be a great case study after.
Yeah. I mean, if I may add, we are doing energy modeling for this project as well, which doesn't have timber, the second one. So we might be able to, we have to reach out to a mechanical engineer and get this answer for you. But we can provide that as well. Yeah.
Yeah, that'd be great. Okay, we have a question from Brandon McKay. You said you have a project underway currently. How do you address the cold weather while the concrete is curing?
So we are using while it's curing. So there's equipment we use for heating the material itself. So make sure it has a constant temperature. So we monitor the temperature where we print. So we use heating or cooling system in the summer. And in the winter now, we're basically enclosing the site. So we are making an environment that is where the temperature is constant so that we're able to print.
And I guess to add to that, just traditional construction sites, as you drive by, you'll see thermal blankets laid over top of concrete. We do the exact same thing as well to heat our concrete.
Great. Thank you. All right, if there's any other questions, just be sure to put them in the Q&A section. Those are the ones we have so far. So I'll ask a question just to keep the conversation rolling. What would you say is, the best application? What projects are well suited for this?
That's a great question. Through our discovery, because at the end of the day, it needs to make sense financially as well. We're really looking at missing middle housing. So anything from 2-story to what we believe right now the technology could go up to, 5 or 6 stories eventually. So being part of the change globally that can scale this technology to address that missing middle housing that many of our communities need.
Yeah, definitely. That's certainly a gap. And what would you say, I guess, where the robotics are right now, what would be your biggest limitations, or are there any? And then do you see it evolving in future to try and address any limitations of what projects it could tackle?
There's a lot, so I'm trying to have it. So some of them is getting code requirements because it's a new technology. So this is a challenge internationally. So each country needs to, prove and accept this new technology. And we definitely started working on it also in Canada. So there's a lot to it. So there's it has to perform structurally, as I said before, right? Fire resistance, acoustics. So all these ratings needs to be put in place. So there's a series of testing that needs to be done by 3D printing companies to get there. So that's I think the biggest challenge there.
And then I guess I would say the other challenge would just be on the people side. Just showing and sharing that this is an emerging field of interest. When we first started in 2020, there were not a lot of people that had the credentials in studying digital architecture, for example. And then now this is something that's found in a lot of universities here in Canada. And then going into just teaching of construction robotics as well. So some of our individuals, specifically the robotic technicians like Romanella, she led the project in Gananoque. She studied robotics and thought that she'd get into welding. So her whole academic career, she had that sightline in mind, and here she was able to build housing and contribute to something that she cares about in her community. So I think it's really just helping people understand that this is just going to continue to grow, this momentum, and it's a journey worthwhile.
Yeah, that's interesting. I guess the gap in education as the industry continues to evolve is trying to get people caught up in that sense. We have a couple other questions here. We understand that progress is a constant evolution. How long do you think it will take you to get to, say, a 50 to 75% of construction?
That's a hard question to answer. I really don't know. Ioulios, what do you think?
Yeah, I'm thinking. I would like to ask Piero. Is it? Yeah. An example of such a firm that you have in mind. What type, of joint venture are you envisioning? And I would add another example of a project. So there's a project called Toralva, which is the highest 3D printed concrete project currently in the world. And there, the floors, which are an essential part of the structure, they printed the formwork with not concrete, but with polymer, and they cast the floor. So it's in a way printing is involved, even though not directly. So I would just add as an interesting example to get closer to that 50 to 75%. I wouldn't be able to tell you how long, though, to estimate it for, residential construction, because, the construction phase itself takes is a long time from design to permit to build.
And I just noticed a second part of that question as well. Will you be entertaining joint ventures with other firms to develop, build, or finance projects using your tech?
Yeah, I would like to hear like an example of what you have in mind there, but we definitely open to collaboration with other firms and technologies. Yeah, because even through robotics, there's multiple things a construction robot can do on site, not only print with the right team and equipment to it.
Great. Okay, and then another one here from JF. How are structural parts included in structural walls? Is it all concrete or other material used like steel?
So it's not only concrete, there is some form of reinforcement that is applied. So it's a combination of the design of the wall itself, the wall assembly itself, and some reinforcement material. Unfortunately, we can't really showcase our method for these projects, our design. But I would like to point out there's an open there's a draft called ICC standards that are for concrete 3D printing, and they show they apply to structural reinforcement and methodology of 3D printed concrete guidelines. So that's also available online to find, and some interesting approaches to it. So it's close to that.
Right. All right. I think that's all for the questions that have been submitted. No new ones here. And then just one other question for me. The height and reach of the robot. So what can it do on the project sites?
Claire, you want to answer that?
Sure, yeah. So the current reach, so we used Val 2.0 for the first project. We were able to achieve interior ceiling heights of about, we believe, it's 9.5 feet. And then translating to a ceiling height of 10 feet, which is wonderful for the first project. And then we're looking to add enhancements to our next robot as well for us to achieve higher heights as well. And then also to Ioulios's point as well, for us to just be able to have to not move the robot as often. But the current robot of Val 2.0, it has a full reach of about 10 meters fully in operational floor space for it to deposit concrete. And yeah, so we built that robot with this in mind of like, how can we make sure that the robot is able to be as productive on site as possible. And we're just continuous improvements from here now that we're continuing to develop next phases of our projects.
Awesome. Thank you. Okay, I don't see any other questions, so I'll wrap up our presentation here. So this is just a reminder for everyone today that today's session was recorded and it will be posted online. So this will be made available on YouTube. In addition to the recording, we also publish a blog, and that will come through in the new year once everyone is back from the holidays. And then that will be available on our website. The slides and the recording and everything does get shared to you via email. So you'll see this come through. That way, if you want to catch up on it later or you want to revisit any of the things that were discussed today, you'll have access to do that. I'll also take a moment to highlight what we have coming next for our webinar series. So this is our January 2026 webinar featuring Aaron Curley from ICI Advisory. The session is titled Speeding Towards Scale, Lessons from the UK and Pathways for North America. We'll be sharing registration details soon, so keep an eye out for that, also from within your emails. And then lastly, we often hear from professional engineers and architects who need to collect professional development hours. So if that is you and you require a certificate of attendance, can you please scan this QR code and fill out the short form, and we'll be sure to follow up with a certificate. I will leave that up here for a moment. So with that, I want to thank you all again for joining us today, and a very special thank you to Claire and Ioulios for a great presentation and a really engaging discussion. And thank you to everyone who submitted questions to keep the conversation going as well. So thank you, everyone. Enjoy the rest of your day, and I hope everyone has a really great holiday season, and we hope to see you again at our January webinar. Thanks, everyone.
Thank you for having us.
Thank you.